All right, so let's talk about the workshop from yesterday. So, right, so just kind of at a high level, what we're talking about is active reconnaissance, gaining information on our target by getting that information from the target itself, right? Somehow connecting to the target and gaining information about that target, right, through the use of these tools. So one, let's just kind of talk at a high level. Let's talk about PWK, right? PWK is a network simulating an office environment. If you haven't already, there, I believe it's at the beginning of the textbook, they kind of give a brief overview of the network environment. You should definitely just read that. But essentially, it's a bunch of PCs on a network. And so here, first exercise, we're going to use Nmap. Nmap is a port scanner. When we say a port scanner, what that means is Nmap will, given a target, right? And that target could be a single machine, or it could be a range of IP addresses, or entire subnet. And Nmap will look for open ports on machines on that target, right? That target or that target range. So essentially, when we start a service on our machine, right? So like, let me log in here. Let me make this. All right, so when we start a service, let me see what's running on my machine right now. So one, can somebody tell me, how do we determine what services are currently running on the machine? Like on my machine, I want to determine which services are running and have ports open on my machine. How would I do that? Can somebody help me out?
The Nmap -A.
So we're not even talking about Nmap just yet, like, right? I'm talking about the machine that I'm on right now. How do I determine what services are running on this machine? I'm like, okay, I'm on my machine. I want to see which services are listening on the port.
Netstat.
Netstat. So Netstat will tell us what services are listening on the port. We use the PANT flags. And if we do that, see, as of right now, nothing is listening on. Oh, actually, you know what? We'll save this for when for 10 o'clock when the review comes. All right, let me just kind of get off track. Nmap port scanner will tell us what ports are open on a machine. Let me connect to the, let me see, am I already connected? And I'm not connected, good. All right, so Nmap will tell us so Netstat is how we determine what services are running on our local machine. Nmap can tell us what services are running on a remote machine, another machine, right? So when somebody starts a service, that service will open a port and listen and wait for connections. And then when something communicates with that or connects to that port and speaks that protocol that service speaks, then that interaction will take place, right? The communication requests and responses will be served back and forth. So Nmap is going to tell us about what services are open or listening on remote machines. So the first exercise here, scan all lab machines to see which host is running a service on TCP port 80. So the subnet for the public network is 10.11.10/24, right? So the IP addresses in the PWK subnet range from 10.11.1.0 all the way to 10.11.1. Right, right, and I want to scan all of them. So another way of saying that range of IP addresses, right, is the subnet /24, where each each of these 4 numbers represents 8 bits. And so we're just saying these first 8 bits, the 8, 16, or 8, 16, 24, these first 24 bits will remain static, and only these last 8 bits will change, right? And these last 8 bits will be from 0 to 255. So what I want to do nmap -p on port 80 of, oh, well, first let me connect. Let's do that. So I'm going to do open VPN mount HGFS PWK 20 West. Well, and I'm going to put that out to var log OpenVPN, connect that log, put that in the background. And to just check and see if that is actually working, I'll just do tail -f var log OpenVPN. Connection that log. All right, ignition sequence completed. That means I've connected successfully. Control C. And then if I've connected successfully, when I do this, I should see this, right? This is my connection. This is the interface that was set up by the OpenVPN to connect to the network. This is my IP on that network. All right, so what I want is I want to find all the IPs running port 80. So I'm going to say nmap. I'm going to tell nmap to just scan port 80. And I'm going to, instead of giving it just one IP address, one particular machine, I'm going to give it a range. I'm going to give it a subnet, right? So I can do this as 10.11.10/24. That run, but also, oh, good. That came back really quickly. So that's good. So here, we see here, and if we take a look, we got back this report and it's saying, okay, 10.11.1.5, port 80 is closed. 10.11.1.8, it's open. 13, closed, open. So this is kind of a lot to take in. So let's do this. Let's do it this way. Let's do the same thing, but now I'm just going to use that greppable format. So OG, and let's just call it, oh wait, let's do this. CD, let's make a directory call and now let's do that nmap command, and let's add the OG flag, right? So the flags that begin with the O, that's our output flags. And actually, no, let's not even do OG. Let's do OA. So we'll just get all of them. We'll give it a file name. It's going to create several files with this base name, just with different extensions for each output type. So let's just call it HTTP. Let's just call it network HTTP. Let that run. And all right, so now if we do Control LS, you see we have network HTTP. We created 3 files: the greppable format, the regular format, and the XML format. We're just going to be concerned with the regular and the greppable format. So if we cat the nmap, we see essentially what was output to the standard out, right? What went to the output. And if we look at the greppable format, we'll get that same information, but now we get it's more compact, right? So now it's that more compact report on it. It's like all of this busyness was kind of removed, and we just got down to the nitty gritty so that we can find what we want. So here's the status of machines that are up, right? These are the status of the IPs that are up, and then the status of the port that we queried, right? Whether it's open or closed or filtered. And so now if I just want all of the machines that have that port open, I'm just going to grep for open from that network HTTP greppable format file. And then here I have all of the IP addresses on the network that have port 80 open. Is Wexler here this morning? I know Wexler.
Yeah, I'm here.
Okay, so Wexler, like yesterday when we were doing it with one IP address, like the kind of the difference was kind of like negligible, but you kind of see now how like with this, like why that greppable format can kind of be useful. Like if I'm doing it over a range, it's easier to just grep and get all that information out of this greppable format form, greppable format file. Whereas if I'm trying to just get that information from this other one, right? So here it's telling me that the port is open, right? But the actual IP that it's talking about is 1, 2, 3, 4 lines up. You see what I'm saying? So it's a little, you still can grep it actually, but it's a little harder, right? And a little harder to it's not that, I mean, so like we could do grep dash, I think it's capital B, is it? Man grep /4 B4. And hold on, let me, because I know there's a way to do it before. I think we had to do it as part of, yeah, so dash capital B. So if I was doing it with the other one, and then how many lines did I say it was? It was so 1, 2, 3, 4. So if I was doing it with the regular output, I essentially would have to do grep dash B, right, open, or grep dash B, 4 lines, open on network HTTP and map. And that gives me the information, but even still, it's not as clean in my opinion, right? So that's kind of where the greppable format comes in, the kind of the purpose of the greppable format. Does that make it more clear, Wexler?
Yeah, absolutely.
Okay. So essentially that's how we did the first one. And instead, if we wanted, let me control L and do nmap. And so instead of giving the subnet mask, I could also just give a range. I could have just said 0 dash through 255. And let's not outputting overwrite what we have already. Let's just do it again, especially since it's pretty quick. It's quick enough. And so see, it's the same information coming back, but instead of giving it as a subnet mask, this time I just gave it as a range. I said from 0 to through 255. So if you're working with a set of IP addresses that don't fit neatly into 8, 16, or 24 subnet, you can just give the range of IP addresses that you're checking. Right. Repeat the scan assuming all hosts are online. Any difference in the results? Okay, so by default, Nmap is going to use ICMP to determine if a host is online and try to then perform the port scan. So we can kind of tell Nmap to just treat everything like it's online. So let's just do Nmap, and it's going to be the PN flag. Yeah, so dash capital PN, treat all hosts as online. So skip the host discovery. So it's just going to, whether or not that server is responding to ping, it's going to still try to do a port scan on that IP address and see what happens. Let's see if we get a different result. So let's do the same thing. Let's do network no ping HTTP. Yeah, let's do the same thing, right? Yeah. So let's do that. And let's see if we get a different set of results. So this one says 42 hosts are online, and let's just see if we can't scroll back and find the previous command, right? And we see, all right, no, so actually we didn't get a difference in this one. Still 42 hosts are online. Still says 42 hosts are online, and let's just do a WC-L on star.gnmap. Oh, Control C, that's not what I wanted. I wanted to just WC-L. And so the no ping in this case did not provide a difference, but there might be instances where there are machines that don't respond to ping but are online and have services running, and Nmap, that PN flag can help you find that those machines and those services that are running. Additionally, another Nmap flag that can be useful is, let's just do this. There is a flag here, SN, which does a ping scan. So it's not going to do the port scanning. It's just going to do a ping scan. It's just going to tell us which hosts are responding to ping. So let's go ahead and let's just do that. Let's just say nmap-sn on this subnet. And this should give us back all the machines that are up on this network. And we see here, these are all the IP addresses of machines that are online in the PWK network. You see there's 42 of them in the 10.11 1 subnet. So, all right, let's go on to the next question. Scan all lab machines to see which hosts are running a service on port 25 and port 110. So this is essentially the same thing. So except before, when we were just doing on port 80, instead, if we want to do 2 ports, we can just do 25, 110. And I'm not going to do that. It's exactly the same thing. You just change the arguments, right? It's the same scanning of the network, but this time we're doing 2 ports instead of that one that we specified, that one port 80, right? Unless, does anybody have any question about what I've done so far? Any confusion? Any questions? All right, great. Now we're going to do scan 10.11.171 and attempt to retrieve OS information. So yesterday I counted the count of the bag. The 10.11.171 is alpha, but now you know. That's why it kind of didn't really matter, because it was already having you target this information. And alpha is going to be the first box that we exploit. We will go ahead and do it as a group later this week. So we're going to spend much of this week kind of showing you techniques, and then we're going to actually go through and walk through the whole full process of exploiting a box. So 10.11.171, you want to know the OS information. Does anybody remember what is the flag to get OS information?
-SO, I think.
Close. It's just -O. And just always remember, we can always just go to that help screen. And I know this help screen is big, but you can, even if this is kind of like a lot, right? You can always remember, you can chain commands together. So what I can do, if I don't want all that information or that whole wall of text, I'm just looking for particular something, I can go ahead and just pipe that and say, pipe that through grep and look for OS, right? And this will give me, right, the flags that have OS in the description. So here are the flags that have OS in the description. You see, if we're just doing just -O, enable OS detection, sorry. -A will do OS detection, version detection, script scanning, and trace route. Right now, we're just interested in the OS detection. So let's just do nmap-O on port machine 10.11.1.71. And so Nmap has kind of a database of different characteristics of different OSs, and then it will, using these how different OSs behave over networks, it would use that database to see how this particular machine is behaving on the network, and then give you a guess as to what the OS is. And so what you will see, OS detect to perform, and well, this OS scan is awful. It says no exact OS matches for host, right? So here it's saying if you know what host it's running, you can submit it here. And then here's some information about the host. I don't know how to read the string. I'm sure it's on the that nmap.org website. There's that reference guide. So I just never took the time to look into this. But so this is actually, I'm actually surprised by this.
We used like the OS scan option as well to make like a more aggressive guess, I guess.
So you did OS scan dash guess?
Yeah, I think that's the command, right?
There is a way to make, hold on, let me, because I don't remember off the top of my head how to make it.
Yeah, it's dash OS scan dash guess.
All right,
And it guesses more aggressively.
Yeah. All right, so let's just go ahead. So let's do nmap dash OS scan dash guess on 10.11.1.71. And let's see if this gives us. Oh, wait, I need to give both. Dash O OS scan guess. Aggressive OS guesses, Linux 3.1241, 94%, 95%. Yeah, so here are the guesses and how confident it is. But even in this range, there's a bunch of things that it's guessing, but pretty much mostly Linuxes that it's guessing. So we'll go ahead and just move forward as if this is Linux, but I wouldn't have any confidence in which version of Linux, or I guess we could have some confidence that it's in the 3 range to 4 range, because all of the ones that it's guessing are in that 3 to 4 range of, here's 2.6 with a 91%.
Frank, excuse me. I did where is it? nmap dot lowercase on os1 from my file -o-pn, and then the IP, and it says that it came up with an IP with the OS details.
Wait, let's do that command again. Nmap, go ahead.
-lowercase on
Okay.
space, and then I made OS1 my file -o capital P lowercase n, and then 10.11.1.71.
Okay, so this is, tell me what these flags mean.
ON is the file that I'm setting up, which is the regular OS1. O is the operating system. PN is to stop the ping, and then that is the IP.
Exactly. So let's see if that makes, so we don't need the ON one. We don't need to say, I don't need to save this, right? You can, you should save this because you're gathering that information, but I guess it doesn't matter. Just keep it, right? Okay. This space is cheap. Host discovery disabled. All addresses will be marked up.
It took a little bit for me though. So I ran something else while I was doing this. Okay, never mind.
Yeah, this is still giving me, this is just like the -O, where it's no exact OS matches.
Because what I have is OS details, Action Tech MI424 Gen 3i WAP DDR Linux 2.4. I don't know why it's the same one, because I saved it and it comes up in the save.
I'm surprised that we're getting different results, and I actually was expecting this. I thought with the -O, I was pretty sure they would have given me like a decent guess. So that's weird. I'm wondering if something has changed, and I'm wondering why you and I running the same command or getting different results. But I guess then maybe that's just the nature of their environment, something with how they have these virtual labs set up. Maybe there's slight differences or something, or maybe just the state of the machine when you scan it, like, because I haven't reverted this box. Maybe, actually, I don't think that should make a difference. Actually, so I don't know, but bottom line, we want you to take away, if you want to find the OS, the -O flag is what you want, right? Scan and attempt to retrieve information about the TCP services running on the machine. Scan and attempt to receive information about the UDP services running on that machine. So to do that, if we wanted the TCP information, right, we could just do Nmap, and we're just going ahead and scan all of the machines. So let's do Nmap. Let's do OA to give us all the output, and let's just call this 10.11.1.71. Let's just call it alpha, right? Let's call it alpha. It's already up there. Alpha, and then we'll just call it all TCP. All right, so we'll get those files with all TCP. And then if I want to scan all ports, somebody remember how we can do all ports?
Dash P dash P dash P dash.
Yep. So -P. So -P is the flag to specify the ports that you want to scan. If you want to scan all ports, just do -P dash, and this will scan all ports. Or alternatively, you could have just given the entire range, right? 0 to 65535. I have to check that 65,000 number, but -P dash is just way easier. And then we do 10.11.1.71. This one I'm not going to run because it's going to take a little bit. Well, we can do this in the background. So let's just do that. Run this in this window, and this will run. Let's open up a new tab. Sudo. And from here, if we wanted to do it for UDP ports, right? So then we're going to do Nmap. Let's do -O A alpha. We're not going to do all UDP. UDP scans take significantly more. So let's just do -top ports 100 -SU. So that -SU is how we tell it to do a UDP scan. By default, it's going to do TCP scans, right? And then we give it that IP address, right? So once again, this is just giving us information about the ports that are open on that machine, the services that are running on that machine. So we'll do that. We're saving this information.
Frank, good morning.
Good morning.
What's the reason that the UDP usually takes longer than the TCP?
It's because of the nature of the two protocols, right? So with TCP, you have that three-way handshake, right? So when I try to talk to a port, when I send it, say, hey, I'm trying to connect. If that port is open, it'll say, okay, let's connect, right? So I'll send that SYN, and then it'll send that SYN-ACK, and then at that point, I know it's open. With UDP, there's no kind of acknowledgement that what you sent was received. So I don't remember exactly how the UDP scan is working under the hood, but the nature of how it needs to go about scanning UDP scans, right? Because there's not that connection, there's not that acknowledgement of, hey, I want to talk. Okay, let's talk, right? If UDP, you just sending your packets, and if you get it, you get it, right? I'm here it is. If you get it, you get it. So because of that nature, that there's no acknowledgement, it just takes longer.
I see. Thank you.
And so here, this was our port scan on this machine, and we kind of just like forget this information. This is all kind of just like, metadata. This is the information that we want, right? Port, state, service. Here's the port, 22 TCP. Here's the state, it is open. And here's the service that it's running, 22 SSH, 80 HTTP, right? So Nmap is just giving us information. It's told us, oh, there's a web server on this page, on this box. This box has a web server running, and it's also running SSH, right? So somebody tell me, what is SSH? Like, I'm sure you all know what HTTP is. What is SSH? Like, what is the protocol? It's a protocol. What is the protocol for?
It's a shell server for remoting into another desktop.
Exactly. So if we can either, right, so if we have a username and password, we can be able to SSH into the server and get a command shell, right? All right, so it's already 10. Let's kind of go on to web enumeration real quick. Create a directory called on your notes called alpha. Nmap scan, we've kind of already done that. Then enumerate details with Nmap by using the -A flag into your target. So -A was going to give us, so this right here is just telling us what ports are open on this machine and the services that are running. But if we want more information about the services, we could, and let's, instead of doing -P, let's just give it the two that we know are open, 22 and 80. And let's do -SV, right? So give us the service versions that are running on this server. So here, run that. Just hopefully this doesn't take too long. And we'll get the service versions, like what version of SSH is running and then what actual application is running HTTP and hopefully a version number that's running. The -A flag is a combination of -O, your OS detection, -SV, your service detection, also the script directory, right? The script files we kind of went over that in that user share Nmap scripts directory. There's a bunch of scripts that can be run to do all sorts of different things, even like vulnerability scanning. Here, OpenSSH is 6.6.1 Ubuntu, so that, okay, we're definitely getting closer to that. This is Linux, Ubuntu Linux Protocol 2.0. HTTP wasn't able to give us any great information so far. Let's run this again with the -A flag. Let's do all TCP, and let's do A, and let's do -A. Right, so this is here running this with the -A. Note that a web server is running and begin poking around with your own eyes. All right, so now it's telling me the server. Why is it giving me that? Unless somebody just reverted the box. Let's see. What's going on? All right, we'll come back and see if this second scan gives us better results. Note that a web server is running and begin poking around with your own eyes, right? So one, we know that a web server is running, so let's go and check out this web server. So it's at 10.11.1.71. Yeah, I think somebody reverted the box because now the web server is not responding as well. So, like we said, it's something must be changed, because for like the first few times we ran this, we rarely had situations where people were bumping into each other, and now like it's the second day and already I'm bumping heads with someone. So perfect timing. Let's go ahead. Let's begin a dirbuster, GoBuster, dir-b scan. So what we're going to do, let's run a scan. Since this machine is offline for right now, we'll just go ahead. We have that list of all HTTPs. Let's just do grep open on network HTTP Nmap, and we're just going to pick a different one and do a directory scanner. So Dirbuster, GoBuster, Derby, 3 tools all do essentially the same thing. They do directory scanning. What does that mean when we say directory scanning? What is that? What's actually happening? What does a directory scan actually mean? Can somebody help me out with that, please?
It's checking to see if a directory exists using that word that matches.
Right. So we're going to provide it with a word list, right? So specifically, like in LS user share word list, right? Let's do Derby. And you see here are all these files that are essentially word lists of common components of a URL, common file names and directory parts or directory paths in a URL, right? Because we know essentially, right, a web server is a web view of a directory structure, right? Your HTML files live in some kind of directory tree, and your HTML, those URLs are a mapping of that directory tree from the root of that tree to the URL, right? So /parent/child /index.html means that there is a folder called parent, a folder called child, and then a file named index.html. And that's kind of, I'm gonna be kind of hand wavy about that because that's kind of changed with some newer technologies where those URLs don't always have to represent an actual file structure, but for our purposes, what we're talking about, we're going to think of URLs as representing a file structure. So let's go ahead and do a scan. Let's go ahead and let's do Dirbuster because it's just graphical. Even though for me personally, Derby is my personal favorite, but.
Frank, I had a question.
Yes.
The word list, is that something that we provide?
No, that is something that, so in addition to so this Kali Linux, right, is essentially all these resources, they've taken like all the best or a bunch of resources for penetration testing and put them on the OS. So some of those resources are actual tools, whether it be like Nmap or Derby, right? These actual applications that we run to actually do some of this gathering, right? Right, these different tools, but also as part of that are these word lists, right? Which are information that these tools use. So if you go to user share word lists, you see right here, I have this rockutext.gz, which we know is a bunch of passwords. It's a huge password file, right? So if you're getting into something where you're doing some kind of password brute forcing or trying to crack hashes, this is going to be useful, this rockutext of this big list of passwords. And then here we have, for these directory scanners, we have these word lists that are common directory or URL words that were found in URLs commonly, right? So when you're using a directory scanner, you need these word lists. So they went out and packaged all this together for you in one place in this distribution so that you don't have to go searching and trying to find all of these different tools when you need them. They're already right there on your machine. So
right. Are they sort of like, I guess, sorted out by industry, or is just everything together? Like if I'm targeting a educational industry, like, or it's just all general?
These are all general. I'm sure there are probably word lists that that are targeted to particular use cases or particular domains. These are not, these are more general, although like you see, there's a list of like Spanish words. So if there's Spanish words, there's probably like a common list of French words and German words as well. Just for whatever reason, I guess because of demand, they weren't included on this Kali that would be something that you would need to research and find on your own. But so in terms of narrowing down the focus of these word lists, you can go online and find word lists that are especially for like passwords. There are password files that are more expansive that rock you and also more focused. And we'll also talk about tools that actually will kind of generate password lists for you. So there's tons and tons and tons of tools. This Kali Linux is kind of like a curated set of, based on OffSec's kind of like most used, most effective, but that's not to say that it's meant to be all inclusive. There are definitely resources out there that are not included on this Kali Linux by default.
And a place to find something like that would be GitHub, I'm guessing, or?
No, sometimes you can, a lot of these projects are hosted on GitHub, but some of them have like different sites. Like there are password list sites, not all on the dark web. Some are like legitimate for people who there are people who do password cracking kind of as like a hobby and build like these really expensive rigs with video cards. But so Google will be your best friend. Start there. And then like if you're looking for a specific use case, start Googling it. It may point you to GitHub, but it may just point you to some guy's site who's just kind of like curating this on his own as a hobby.
Thank you.
All right. So, okay, directory scan. So directory scan, here's Dirbuster, and we'll give it our URL. Did we pick a URL? We didn't. Well, let's see if 1071 came back. Okay, so yeah, somebody must have reverted it. So let's go back to 71. Let's go ahead and just do http://10.11.1.71. Also,
there's no way to paste in there, is there?
You know what? I don't think I've ever tried, but I'm sure you can.
I tried and couldn't do it.
Let's try it. http://10.11.1.71. Copy selection. Nope. There's no keyboard shortcut. The shortcut's not working in. Oh, okay. So apparently not. Which is odd. That's a weird omission. It's kind of like the basics. All right, so that's our target URL. Here is where we give us a little graphical way to select our word list. So we'll go browse, user, share, all the way down at the end. Word list, let's choose the Dirbuster, and let's just go let's go small. Select that list, and blah, blah, blah. We'll just go ahead and start it. So we'll start that. It's going ahead and searching. You can see here for directories, kind of what it's kind of starting with. These are the directories that it's testing. Here in this results view, we kind of get what it's found, right? So this CGI bin is here, but it's forbidden, right? The response code. So we're talking about those HTTP response codes. So this exists, but we're forbidden from looking at it. So if we try to go here and try to go to /CGI bin, we'll get a forbidden. All right, so that's there, but we don't have permissions. Templates, icons, site. Here's templates, config.php, right? So this is interesting. Like, what do we think this is? Config.php. When you see if it's a file called config, what does that make you think?
The configuration for that server?
Yeah. So there's probably some good, there may be some good information in here. Maybe we take a look at it, and it's a 200, so we can just see it, right? So we'll go in and take a look at this file, right? So scanning with your own eyes, using one of these scanners to get more information. While you scan results, poke at the directories and files found. We need to do that, and then begin looking for web vulnerabilities with Nikto. So directory scanners kind of give you more things to look at, right? They're uncovering things that aren't surfaced naturally. So like right here, there's not a way to click to that CGI bin link on this blog site, right? There's no link to that config PHP on this blog site, but using this directory scanner, we're able to uncover it and find it, right? We're able to kind of using just common words that humans are going to use to name things to find that information.
So I have a question.
Uh-huh.
The Dirbuster thing, it says the time to finish is 19 days. Does that actually, like, how do you know when you're actually ready if it's not gonna be done for 19 days?
I don't remember ever seeing this be like this large before, but then actually I don't remember actually really paying attention to this as well, because as this thing starts to come in, right? Like something like a directory scanner, which can take a little bit of time. Like definitely not gonna wait 19 days, right?
Frank, is that recursive?
Yes, this is recursive.
Oh, that's why it's 19 days, isn't it?
Yeah. So Dirbuster and Dirb are recursive. GoBuster is not. But like while this information is coming in, like I would like kick this off, do something else, and then like let it run for a little bit, and then I come back and I start poking and looking at things. Right, I must just start looking at what it's found and going in here. So I don't think that you need to let this run for forever, like especially when it's something like this, like 19 days. You're not expected to let this wait and run 19 days. And like, for instance, like we've already found this config file. That's probably going to set me on another path. This is likely to have opened up other avenues for me to look down, right? And also, while this is running, I'm also going to run Nikto, right? So let's go ahead and do that. And Nikto is going to actually scan that website for vulnerabilities, right? So not so much the directory scanner is kind of uncovering information, but that's not necessarily vulnerabilities, right? It's just kind of surfacing and kind of mapping the site out for me a little bit. But what I really want information on is possible vulnerabilities that exist on that site. And so that's kind of where Nikto comes into play. So Nikto comes into play because Nikto will just kind of scan the website and actually just try to find vulnerabilities that are present on that server. So here we'll just give Nikto the -H, right? And then if you're curious about what the other options are, there is the man page, which you can also just kind of run it with no options, and it'll kind of spit out what the flags are, right? For me, I rarely use any flags. Sometimes I'll use the output to just kind of output the information to a file, because you can output the file to an HTML format so that you can then open it in the browser. But even then, I don't use that much because that file isn't, I don't know, it just looks so 1995 that sometimes it just turns me off looking at it. So anyway, Nikto will tell us about actual vulnerabilities on the site. So Nikto-H for the host that we're going to scan against, and we'll run that, and we'll let that run. And then actually, I'll let you, that's really all you need to do. And then it's going to give you a bunch of information. Go ahead and just take a second and look through that information. And I don't want to, there's good information, there's valuable information here, but I want you to find it on your own. It's Nikto-H is all you need to do. So just hint, it's going to tell you about a vulnerability that's going to be promising. Begin a more comprehensive directory scan. We're not going to do that. And then what are the most important findings from your recon? So right now, I would say is one, the services that are running, right? HTTP and SSH. That's kind of helpful, right? That we scanned all the ports and there are only 2 services running, right? If you scan a server, and you will find servers that have, 5, 6, 7, 8 ports open, 8 applications, but then that essentially means there are 8 possible roads to go down to find an exploit. Here we have 2 roads. Our way in is either going to be through SSH or through HTTP. And just because of the nature, like, not to say that SSH is not vulnerable and SSH is never the way, but SSH in general, if it is a pretty secure protocol, it will not often be the way that you get in terms of a vulnerability in SSH. You will find ways where you will use SSH as a vector into the machine, but it's because you will exploit other vulnerabilities and find information that you can then use with SSH to access the machine. So like right now, as far as I'm concerned, I'm going to just be looking at HTTP as my attack vector for this machine. So that's kind of what we were gunning for with that workshop yesterday. Is these tools are just, especially when you're talking about web, you should just automatically say what you should try. Just right now, you should just try Derby, try Doorbuster, try GoBuster. You'll develop a preference for one or the other based on your own personal style, and then once you have made that choice, just Nmap is going to be like default. You need to find out what even your roads are to get that roadmap of what are the forks in the road that I can possibly take on this machine. That's where Nmap comes in. That's your opening information, right? That's your, okay, what are the possible ways that I can go about attacking this? Like, I can only attack services that are actually running, right? Nmap will give you that information. Nmap will tell you what applications are running on that machine. Then in terms of what the particular applications are, there are, for these different protocols that are running, there are tools made for attacking these different protocols. Where right now, just talking about web, because this is going to be a common attack vector. So when you see a web, first things you should do, once you've done your Nmap scan, you see a web server running, the first thing you should do, go to that website, just start poking around, pick your directory scanner of choice, run that while you're kind of looking at the site, and also run your Nikto scan while you're looking at the site. You can all go ahead now, do your Nikto-H on Alpha if you haven't already. Go ahead, take a look at save the output, right? So you can either however you want to save the output, you can use redirection, you can use that T utility I showed you yesterday. You can use the -O flag that's part of Nikto, whatever floats your boat. Save that information. So like create that directory, save all this information that pertains to Alpha so that you kind of have it, you don't have to look at it again. And then look particularly at your Nikto scan if you haven't already and see if there's any interesting information in there. So I think that's pretty much, any questions about any of these utilities or this approach that we're doing to get this information about servers and applications?
How reliable is Nikto?
So you will find in all these things, right? None of this is bulletproof. There is no easy button. There is no something you're going to run is going to say, hey, just do this and you're golden, you're in. Nikto is going to give you a lot of information and it's going to shoot to give you more information. It's going to suit or err on the side of more information. So some of the information that you give me, that it gives, right, might not be useful. There are times that you might run something and you don't get anything useful from that particular scan, right? But all of the information that it gives you should be reliable. You'll learn there's going to be information that you're going to see like every time you run a scan, like, oh, this is always the case. This is just be something that's just always around, and you'll just kind of learn like what to ignore, but that's just something that just kind of comes with time. But in terms of finding vulnerabilities, Nikto is a good tool.
Thank
All right. So with any other questions? Anybody still fuzzy on the kind of the use of any of these tools, or like where they fit in, how they fit into the big picture? All right, so let's do this. Let's take a 5-minute break. I'm going to go ahead and let me stop this recording.